Hello, and welcome back to another festive coding session with Mr. Jacob. Together with our trusty Grinch here, we will now implement the next installment on the advent of languages, where we strive to implement on each of the 24 days in December, the first 24 days until Christmas, to implement the same thing in another programming language. And we want actually to implement an ASCII representation output system for one of those neat little Christmas trees. And we did this before for a couple of other languages. And today, it is something special. It is a special language which has a special place in my heart because it essentially was my first programming language. And therefore, without further ado, let's switch to it. It was Amiga Basic. And we are today going to implement our Christmas tree in Amiga Basic. So let's open up Amiga Basic here. As you can see, I've already prepared an Amiga here with the corresponding Amiga Basic version that I had when I was a child and first did some programming. And I did that with exactly that basic version. Okay, so now we have our basic interpreter here. We can do a couple of things. For example, we can issue something like a print command, for example. We can do something like this, and then we can tell the system that we want to run that, and it will run it and tell us, okay, hello Christmas. Okay, now we can do a list again and get our list view back. So Amiga Basic, in comparison to other basic dialects which were there before or even there at the time, had a couple of nice features. As it was using Amiga's Workbench system already, it had the capability of having different windows, for example. It had the capability of having an editor where you could move around and change things, actually. Um, you didn't necessarily need, even though you could, prepend things with a line because you had a full-fledged editor which you could use to essentially change things after you have printed them. Usually you would, otherwise in other editors of the time, you would specify the line number then and rewrite the line if you wanted to change something. We have the benefit of being able to edit things here like we want to. So I guess we will get started kind of like we do always. We are going to start and implement our Christmas tree functionality. So how do we actually do that? Yeah, we are going to define a variable as always, which is groups, which defines us or tells us how many, and let me quickly switch back to this README, how many of those groupings here, like this Christmas tree groups here, we want so that we can modify that in a way that we like. We are usually specifying that as a variable, and we are doing here as well. So let's specify those groups. Let's, for example, tell the system we want 6 of them, and then let's call a subroutine. In BASIC, actually, there are no functions, there are subroutines. So we call the subroutine draw tree, and we give it the groups. And there is something important there, for example. Even though I haven't written the subroutine yet, I couldn't do something like, for example, this. I couldn't tell the system that I want to draw tree with a specific literal. If you pass a variable in Amiga Basic to a subroutine, it always needs to be within a variable first. So you always need to specify a variable, and then you can pass that to a subroutine. Okay, once we have now our drawTree function that we call there, let's create a subroutine called drawTree. So we are simply telling the system that we want a subroutine drawTree, which takes an n as an argument. And by default, all arguments are actually numbers in BASIC. If you want something like a string, for example, which we might see later on, we need a special notation there which ends on a $sign. So I would then need to do something like that to denote the type. Furthermore, in Amiga Basic, we are forced to create static subroutines. which actually means that every variable that we are using within a subroutine will be static. So it will live as long as our program lives. So if I would have a variable here called x, for example, and I would say that x is x plus 1 each time that the subroutine is called, the state of x would be held in memory when this thing actually runs over and over and over again, and it would increment sort of a counter there. So that means that something is static. It is in Amiga Basic, only static subroutines exist. So actually Amiga Basic enforces that this static portion there is actually printed out. So you need to specify it. You don't even have a choice. Every subroutine needs to be static. You end a subroutine with end sub, and that is what we are doing here. So now let's put some content within our draw tree subroutine. Usually what we do first in our subroutine is, as I've said, draw our groups. So the amount of groups that we want to draw, we are calling a function for called draw group, and we can do more or less the same here, I guess. So we are doing a simple for loop. So for I from 0 2, and then we specify the end. And actually the end is inclusive. It's not exclusive, it's inclusive. So it will iterate from 0 to specifically this end. So yeah, most of the times you are iterating in BASIC from 1 to something. However, for our logic, I guess it will be a little bit neater to start from 0. So we are iterating I from 0 to n. And how do we actually end for loop in BASIC? That's actually an interesting thing. You don't do something like end for or end or something. You call next, and then you call the next of the loop, the iteration variable there. So I say next I, and this actually ends the loop and jumps back again to the start of the looping condition here and checks that. Okay, so now we have our loop there, so we need to fill it with life. So let's do a call to draw group. And our draw group function, we need to first of all give the current I, and we need to specify or give it the maximum amount of groups that we are going to draw. We need both of those information to calculate the spacing of the tree correctly. So let's see what happens if we now specify our function here, our subroutine, sub draw group. So this one takes n, which is the current group thingy there, and it takes length. We can't use len because len is, again, as it was before in certain languages, a specific element, a specific keyword in the language. So, and we need to define this as static. Let me move my mouse cursor out of the way. And we do end sub here again, just to be sure to have ended it properly. Okay, so it's a little bit of hard to use all this different key bindings here, because navigating the keys needs certain function keys to be pressed and stuff like that. And it's a little bit hard to actually do that. However, I I think I'm getting the hang of it. So if you see me stumbling around in this editor, now you know why. Okay, so in order to draw the group, we first of all need to print out something again. And in order to see if what we are actually doing here works, we could try and simply print out the n there, so the group that we are currently drawing. As you have already seen, a print always ends with a new line, and we will see in a second how we can actually not print a new line. However, let's for now check that our code that we have written so far is actually running. And as you can see, it is. So it printed out the numbers 0 to 6. So it rendered exactly 6 groups. And there is something that we already did wrong. Because, as I have told you, the n is inclusive. So we only want to go from 0 to 5 because we need 6 iterations. So we need to go to n-1 here. So let's run this again and let's see if this now fits. Okay, now we have exactly 6 iterations. So 0, 1, 2, 3, 4, and 5. Perfect. So our code so far is working quite nicely there. By the way, if you are wondering, I have configured this emulator here to be the exact speed of my Amiga 500 at the time I had it. It only has a little bit more RAM to make things a little bit easier for us. However, the speed is exactly the same. So all the drawing that you see here on the screen is slower. And something else that I might want to mention is, and we might come back and revisit this, even though it would be the same language we will see, is that Amiga Basic actually had extensions to do graphical drawings. So we could actually draw a graphical Christmas tree on screen. We will see if we can come back to that, maybe in another video at another time and not part of the advent of languages. You can tell me in the comments if you would be interested to have that. I would be glad to be informed about that. So, okay, so now where were we? We were at drawing groups. So let's remove this code again. How do we usually draw groups? First of all, let's go back to our tree here for a second. We need this spacing here. So we need some sort of spacing calculated until then our group starts. Then we need the slash, and then we need spacing in between these parts of the tree where we could or may print ornaments, for example, like for example this here, and then we need a backslash again, and then a new line. So the calculation is actually quite easy. The spacing here is always the amount of full groups that we have minus the group level where we are in, because we need to move further left for each group that we go down, and each line down we are subtracting 1 as well because we are moving 1 further to the left. So let's implement that, I guess. We can actually maybe create another subroutine here to not have the same loop over and over again everywhere, which creates the spacing for us. So what we could do is we could do something like call space here, and we give our space what we just said. So length minus n. But do you remember something? Do you remember I said this is not possible? We will try it anyways to see what the system might tell us if we try to do that, because we need to first define it as a variable before we can pass it to a subroutine. However, let's first quickly implement this subroutine. Subspace, which takes an n and is static here. And what we simply do there is, because we simply have no other means of doing it, we are doing a simple loop again from 0 to the n minus 1 here. And in this space, we are doing a printing of spaces. And now we want to print a space there, but we do not want to print a new line. How do we actually do that? There is actually this specific thing. If you end the print statement with a semicolon, it will not print a new line. That's actually defined like that. So let's do that. That's the way to not print new lines, to only print the characters. And now we can actually do here end sub. And if we now actually run this, it should not work. Okay, it does work. Maybe it is because we can have arithmetic in our subroutine calls, but not literals. Because if I would have done something like, and I'm quite sure that this does not work, if I would have done something like that, exactly, we would get a type mismatch because we specified it a literal value instead of a calculated in there. Or is it because I've actually no idea. I'm quite. It's quite interesting that this actually works. I mean, I like that this works. It makes the code a little bit neater, but yeah, okay. So good to know. I've learned something as well. Okay, so we have now drawn the space out. Now we need to print our slash there. However, we don't want a new line as well, so we end it with a semicolon. Then we are going to need to print out the spacing or ornaments in between the the tree. So I guess I will call that function ornaments, and I will give it the corresponding length as well. And the length actually is n times 2 in this case. And let's quickly implement that function as well. And now we can do something that we couldn't easily do in older systems as well. We can actually copy this thing here and then insert it again. And yeah, it is a little bit cumbersome, but at that time it was simply awesome that you could do that with a computer. So now we can call that ornaments. And essentially, at the moment, we are only printing spaces as well. And we will hopefully come to the point where we draw ornaments then later on, once we have our tree there. So let me remove this new line here, which we don't need. And now we should actually have the correct spacing there. So now we can print our backslash. And this time we don't put a semicolon there because we want the new line. So what did I press now? I pressed escape. Reflex from using the eye. Okay, so now let's go back to our window here and let's see. And we have already a kind of a tree. However, we only did one of the group layers, so we need the other group layer there. So we can copy and paste again. So let me quickly mark this up here if it would work, which it doesn't currently. Why doesn't it? Now it works again. Okay, so copy. And now we go at the position where we want and we do paste. Yes, and let's quickly clean that up. And what we actually want to do here now is we do one less here, and we will see if this now works or if we need to put this then in a variable, because now there's a little literal in this calculation, and the ornaments are actually getting n minus 1 times 2 before being printed out. So this is kind of creating this zigzag shape of the tree. So let's see if this actually now is done. Okay, it is not. We did something wrong there. Let's see what we did wrong there. It seems to me that in the second one, the spacing actually of the ornaments is not right. So what's its problem here? Wait a second. That's... Oh, it's not -1, it's +1. I did the wrong calculation there because the second one needs to be wider, not shorter. So, okay. Now, as you can see, we have our neat little Christmas tree form. Okay, the next step to work on would then be to actually not only draw the group here, but go ahead and draw our bottom line there as well. And we can do this with a simple line there as well. So what we can do here is for I, 0, 2, and we by now know how to do this. This would be 2 groups. No, to n actually, because it is called n in this subroutine. So to the amount of groups that we want to draw actually, times 2 plus 2. That is actually the amount that we need to draw these minus signs there. Okay, so now we do a print again of the minus sign, and we end with a semicolon to make sure that we are not jumping into the next line for each of those things, and we do a next I. So let's see if this actually works out, and as you can see, this works out. It kind of looks like that there is one too much. There is one too much. Yes, there is one too many. Sorry, not much. Many, because I already forgot again that this syntax just is to me like go from there to there, but do it exclusive and not inclusive. So I always forget that I have to do -1 here. So if we do one less, then it will fit properly. as you can see here now. Okay, so now we have that, so we only need our trunk. So let's create quickly a function that draws our trunk. So sub draw trunk, and the trunk needs information on how many groups there are actually as well, because it needs to calculate the middle point of the tree. So we can quickly do that here. And then if we go up here, we can easily go ahead and do a call to space. It's a good thing that we did this subroutine here, and we print out n spaces, so exactly as many as we have groups. Then we simply print out where is this on my keyboard here? Let's see, there 2 pipes there as the trunk, and we go to the next line, and we are doing that actually 2 times. So let me quickly type this out here. I guess that's faster than doing copy and paste. And I pressed escape again, like a reflex there to switch to VI command mode, but this is not Vim. So did we already call that here? We did not call that, so let's call draw trunk n, and let's see what now happens if we have actually a fully fledged tree now. And we don't, because we did something. Oh, we did never return to another line here. So that's actually an interesting thing there. We need to, when we actually draw these lines here, that's an interesting bug. We are never doing a new line, as you can see here. So what we actually want to do is we want to draw even one less, and then in the end, we want to simply print one with a new line. Because I'm not sure, we could actually, come on, we could actually try that, but I'm not sure that you can just print a new line. I guess that's not really possible. So let's do it like that. And now we have our Christmas tree. And let's quickly add some randomized ornaments there, shouldn't we? Because essentially we are finished, but what would the world be without ornaments on a Christmas tree? So let's go back to our ornaments function that we created as a good idea here on how to do that. And let's see how we can actually create random values in Amiga Basic. And that was actually something that I had a lot of fun with when I were first programming. I did a lot of stuff where the computer did something randomly, and that was quite awesome at the moment when I did that to me. So what we can do is we can do a normal if statement here, for example. And what we have is something called RND. And RND actually gives us a random number. And it gives us a random number between 1 and 0. Between 0 and 1, yeah, it's essentially the same thing. However, what we can do now here is we can say, for example, if RND is less than 0.1, as always, or 0.2, like if we are in the range of, for example, 20%, then we want to print some ornament here, something like, for example, an X. And otherwise, we want to print the spacing, and this would be and if. And I did escape, I pressed escape again, and we can indent this, and we can indent this, and this might already work if I'm remembering correctly how this works, and I don't. It is a syntax error. Okay, what did I wrong there? Something I did wrong there. What could be wrong there? If RND, so RND gives us the number, is smaller than 0.2, then. Interesting. Oh, I see. Because, yeah, that is the syntax error, because I forgot to put the 1 here. Because usually random gives you a number between 0 and whatever you specify there. So we want the number between 0 and 1. And now, let's see if this now actually might work. And as you can see, now we have ornaments on our tree. However, we might even want more ornaments or different ornaments. So let's define something like We could call that chars. And now you will see that I define that as a string with this dollar in the end. And we could something like UIOX, for example. That would be nice little ornament chars, wouldn't they? So in this case then, when we want to print an ornament, we can do a little bit more than just printing one of the ornaments. We could do a print of, and now there comes another function into place, which is mid. Mid actually is a function working on strings. Therefore, you need to specify that dollar there as well. And mid is kind of substring. You take a part of a string. You can specify the starting point and you can specify the end or the number of characters that you want, and it will simply cut that out of a string for you. So now, first of all, which string we want to take from chars. Then what do we want? We want an integer casted version of an RND of 1. Of another function here. We are taking the len of chars, I guess, then there. So we have now len of chars in our mid function, and that is a unfortunate scrolling there, actually. Can I? Yeah. Can I actually put that? I have no idea if I can do that, actually, what I'm currently doing here. I have no idea if I can break this into the other line. Let's see. So we take the len of chars. So we generate a random number between 0 and the len of the characters. And then we are simply saying to that thing that we want one character. I'm not 100% sure if mid actually is 0 or 1 based. I would assume 1 based because most of the basic functions of that time were 1 based, not 0 based. So this could already do what we want it to do. And we want a semicolon at the end, of course, because we don't want to jump into the next line. So let's just run that and see if that works. Okay, it does not. Missing operand. Okay, the problem might be that this can't be in a new line. So learned something again, that this does not work out if it is in another line. So let's see if it's now running. Same problem, I guess. Okay, syntax error. That's, as you can see, very specific that this is a syntax error there. So where might be the error? We are printing, we are using mid, we are providing the input here, then we have an int there. Let's see that we have the brackets right. So what we actually want is we want an RND to the len of the characters here, and we have a closed one, so this one, so we didn't close the int there, so we might be missing a character, a bracket there. Let's see if this now does what it should. Okay, no, it's illegal. It's an illegal function call now. Interesting. Okay. What did we wrong there? What did we wrong there? Let's see. The question is, can we actually generate random numbers that are bigger than 1? Let's quickly check that. We can execute basic code here in like we want. So, okay, this does not work actually. So can we do, if we do, if I put an equal sign at the end, it will not work as well. So if we do random 1, it does. Oh, yeah, of course not, because we need to do something with this value. So if I do 5 here, it essentially gives me, okay, so this kind of works. However, I'm not sure that, but rand 5. Okay, it might give me always, even though I'm not specify or completely irrelevant what I specify there, give me a random number between 0 and 1. I'm not 100% sure actually. Okay, so it seems that we need to put something in there. Can we do something like foo equals 5? And if we don't do foo, random foo, okay, no moment, just a moment. We had print, we need print there, random foo. Okay, this works as well. So nevertheless, it gives me something between 0 and 1 all of the... No, it does not. It now gives me... Oh, yeah, okay, it's an exponent thingy there. Okay, so at least something is a little bit weird there. So let's do this another way. Let's maybe just do it like that. Let's take a random number between 0 and 1, and then simply multiply this with the len. This might work then. Let's see if this solves our problem. And no, it did not. Okay, illegal function call, which lets me to believe that this might be 0 indexed actually after all. So let's just subtract 1 here and let's see if this then works. No, it does not. Okay. Yeah, so that's kind of a a disaster now. We might need to leave it at that without being able to fix that. So as we are running out of time now, I would have hoped that this goes a little bit quicker. So I'm getting the length of the characters, multiplying it with the random value thingy there. So, that's interesting. Maybe we need to specify that in the range. It could be a problem that we are actually... Wait, did I just subtract 1? I wanted to add 1 to make sure that we are always in the range 1 to len. Okay, so let's see if did I just do that wrong? Okay, it seems that I just did that wrong in my head. Okay, and as you can see now, we are always getting the same result because we are essentially always using the same random number system. So we need to initialize the random number generator here at the start of our program, and you do that by calling rand something. There is a call that I just don't remember now where we can use the system timer to actually call randomize. So okay, I quickly looked that up and it is actually randomize. Randomize, and we give it the current timer. So if I do something like print timer, it simply gives us the elapsed time in some sort of tick format. So, and if we do randomize with the timer value, we are essentially every run randomizing the thing in a different way. And as you can see now, it is printing different ornament setups here on our tree, which is a neat example, I guess. So let's see, how big can we do this tree actually? Would 9 still fit? Yeah, 9 still fits. I think that is the biggest that we can go there. So we now have successfully created in Amiga Basic an ASCII art tree with ornaments, as you can see when I run it here in the background. And it's not the fastest thing at all. However, it was a lot of fun as a child to play around with that. And as I've said, if you are interested in that, please leave me a comment. We might do this again with the graphics basic capabilities of Amiga. Even so, if you would be interested in more like this retro programming stuff, tell me as well, maybe in the comments. So we could do something maybe in 6502 assembler or in 6800 assembler, like for the Amiga or stuff like that, or could take a look at how to actually operate a system like that and program a system like that. If you would be interested, we could do 1 or 2 videos on that. So tell me if you are interested, and I hope you had fun while we were doing this programming session here on this day of the Advent of Languages. And I hope to see you tomorrow for the next one. So have a great day and see you. Bye.